All right. The answer to number 1. The answer to number 1 is D. So, the math that you should have done is you should have factored. And if you look at the bottom, it's in the wrong order. So I'm going to write negative x plus 2. And then I notice that on the bottom I can factor out a GCF of negative 1. And those factors cancel. So x plus 3 divided by negative 1 is negative x minus 3. And now if you do direct substitution, you plug in 2, you get negative 5. Remember, when you find the limit, you always try direct substitution first. It's possible that it could work. It's possible. All right. The answer for number 2 is A. So on this one, we needed to multiply by the conjugate. And the conjugate is square root of x minus 5 plus 2. Square root of x minus 5 plus 2. What I might do, I just want to make sure we can get through all these problems. Maybe we'll, I'll just keep going, and then if you want me to show you all the steps, stop me and have me show you the steps. Okay? Anyone want to see all the steps on this one?
Yes.
Yes. Marvelous. Let's do it. So, to simplify this, we need to FOIL out the top. So what happens if you do root x minus 5 times root x minus 5? It just becomes x minus 5. Okay? And then you have 2 times the square root of x minus 5 and negative 2 times the square root of x minus 5. Those cancel. I'm going to go ahead and write them just so we can see that they cancel. And then we have negative 2 times positive 2. Negative 4. And then if you guys remember, it's actually better if you do not multiply out the bottom. So x minus 9 is being multiplied by the square root of x minus 5 plus 2. Alright. So we can cancel these out. What does that leave us with? And then what do we see? The x minus 9 cancels, and we have 1 over the square root of x minus 5 plus 2, and now what do we do? Yeah, now we do direct substitution. So if you plug the 9 in, you get 1 over the square root of 4 plus 2, and the square root of 4 is 2. 2 plus 2 is 1/4. One thing that came up before was just wondering, do we do plus minus of this square root? The answer is no. If the square root's already in the problem, you put this in the problem as a positive square root. The only time you do plus minus is if you are solving a problem and you take a square root as part of solving a problem, then you have to do plus minus. Does that make sense? But since the square root is already there, we already know it's the plus version. All right. The next one, the answer is, anybody know? B. The answer is B. On this one, we had to undo the complex fractions, and the easiest way to do that is to multiply by that common denominator on the top and the bottom. So when you take 2x and multiply it by the first fraction, you just get a 2. The x's cancel. When you take the 2x and multiply it by the second fraction, the 2's cancel, and you just get an x.
Why are you multiplying by 2x?
You multiply it by the common denominator. It's just the easiest way to get rid of fractions. Is whatever the denominator is, just multiply by that. We also did that method with partial fractions, if you remember. So we got 2x times x minus 2. And then again, as part of our simplifying, we want to put these in the right order. So negative x plus 2. And again, we can take out a GCF of negative 1. And at this point, we can just plug in, we can do direct substitution. Yep, so negative 1, 4. And again, if I go too fast, I'm videotaping it, so it'll be up on the website. All right. This one is one, you can clearly not simplify this, right?
Yeah.
Like you're looking at this like, what the heck should I do? What is the first thing we should always try? Direct substitution. This is one where direct substitution works. So tan inverse of 1, sine inverse of 1, plus 1. When a problem is saying tan inverse, what type of answer are we supposed to get? An angle. We're supposed to get an angle as an answer. So this is saying if I have a y divided by x on the unit circle, a y divided by x that's simplified to be a 1, what's the angle there? Pi fourths. If I look on the unit circle and I have a y coordinate of 1, what's the angle there? Pi halves. Plus 1. Now, you don't even have to simplify the problem. We already know what the answer is. Because it can't be any of the other ones, right? Okay. If you wanted to simplify it to get it to actually look like the right answer, we could get rid of the fractions. So what could we do to get rid of fractions? Multiply by, what's our common denominator? 4. Common denominator is 4. So I'd multiply the top by 4 and multiply the bottom by 4. So when you do 4 times the top, what do you get? Pi. And then when you distribute the 4 on the bottom, what do you get? 2 pi plus 4. So you didn't need to do that. You could already kind of tell what the right answer was, but let's do a check. Yeah.
Are these like questions from
And actually, if you flip back to the previous page, yeah, it tells you exactly what years they got them from.
Oh, that's what that was for?
All right. Number 5, what do we get? E. It does not exist. Why does the limit not exist?
Because you can't two values.
Yeah, your left-hand limit is -1. Your right-hand limit is 0. Your left-hand limit and your right-hand limit do not exist. Or they don't agree with each other, therefore the overall limit does not exist. All right. What is like the definition of continuity until you get to calculus? How do we define continuity?
You can put your pencil and you can draw.
Yeah, you can draw it with your pencil without picking up your pencil, right? If you think about piecewise functions, is that often the case? You can draw it without picking up your pencil? No, what usually happens? There's usually a jump, right? Somewhere in the graph, there's usually a jump. For that jump to not happen, like right here, there's a jump, right? For that jump to not happen, you have to have the same y coordinate. So if I plug this x coordinate in, I need the function, or the y coordinate, right? Whenever they say the word function, they really mean y coordinate. I need the y coordinate to be the same when you plug that x value in. As long as the y value is the same at that x value, then I'm going to have a continuous function. So what we need is if you plug in pi for the first function, so sine of 2 pi, I need that y coordinate that I'm going to get from that to equal if I plug in pi to the other one. So 2 pi plus k. And then what is sine of 2 pi? 0. So I need 0 to equal 2 pi plus k.
So negative.
So k is negative 2 pi. So that's it. On number 7, does direct substitution work? No. Why does direct substitution not work? 1 divided by 0, you can't have that. So, yeah, so the idea is if you can't do it with direct substitution at first, you try to manipulate the problem after that. What is the only manipulation you know how to do? Distribute. I don't know anything else I could do, so I'm just going to go ahead and distribute.
Is there anything else you can do?
I don't think so. So that gives me x times e to the x plus x over x. X over x is 1. So if we plug 0 in now we can do direct substitution. We're going to say 0 times e to the 0 plus 1 equals 1. Identify the vertical asymptotes. What answer choices can we already get rid of? D and E. Why can we get rid of D and E? Those are horizontal lines. So they're not vertical asymptotes because they're horizontal lines. Alright, what do you do to find vertical asymptotes? Factor it, right? So the top is
X plus 4, X minus 1.
and the bottom is
X plus 2, X minus 1.
okay, so do we have two vertical asymptotes or just one? One, because one of them is canceled out, which is a hole. So we got a hole at 1, we got a vertical asymptote at -2. So the answer is B. Alright, this one, I don't know about you guys, but this one hurt my brain as soon as I started reading it.
I didn't read
So what I did is I kind of recognized that it was getting at the intermediate value theorem. Do you guys see how I could understand that? Or I could get that?
It's because it has the C.
Because it has the C, it has like this inequality right here. So here's what I did. I said it's a continuous function, so I said my first step is that it's continuous on 1, 3, right? That's the first step of the intermediate value theorem. The second step is to plug in 1 and plug in 3 and see that you have that inequality. I can see that they showed that. And then my third step, I went ahead and I wrote my sentence, by the intermediate value theorem, there exists some C on 1, 3 such that P of C equals K. I just wrote it out. And then as soon as I wrote that out, I realized that only one answer made sense. C. C is the only one. If you think about what the intermediate value theorem tells you, C is the only answer that makes sense. So before I did the problem, before I knew that this is what it was talking about, and I was just reading everything, I felt very confused and I wanted to skip it.
Me too.
Then I sat down and I was just like, this is the intermediate value theorem, I can tell. I wrote out my 3 conclusions, and then it made it really obvious to me that the answer was C. That is a good strategy. Anytime you're doing a problem that feels overwhelming, where like the answer choices are maybe confusing, ignore the answer choices. Do the problem if you know how to go through and do the problem. Because when I looked at this, I was like, this messes with my brain, but I do know how to do the 3 steps for intermediate value theorem. So sometimes the way that the answers are phrased might mess with your brain, and in that case, you need to not look at them. Okay? It's a good strategy. All right, next page. How do we find vertical asymptotes? They're factors, right? They're factors that are on the bottom that don't cancel out. And we already know there's a 1 on the top, so are any of the factors going to cancel? No. All right. How do we factor that?
I substitute.
So 2 sine x plus 1 and sine x minus 1 equals 0. Now, I knew when I looked at this, I was like, there's 2 vertical asymptotes. That was my first thought. And then I was thinking, but why would they do that? Because then you could just look and be like, oh, it's squared. There's 2 vertical asymptotes. You wouldn't even have to factor it. I was thinking to myself, like, why does it say 3 and 4? Why are those like valid answer choices? Because you know when you're taking the AP calculus exam, there's no easy ones necessarily to cross off. Or just like, there's reason to give you pause. So then I was thinking, oh, if I solve for x, right, because sine x is not how an axis is numbered, it's just x, right? If I solve for x here, so that I could say where my vertical asymptotes are, what do I get?
X equals,
Well, sine x equals -1/2. What does x equal? So unit circle, 7 pi 6 and 11 pi 6. Okay. Over here we have sine x equals 1. And that's pi halves. So how many vertical asymptotes are there?
7.
3. Alright? Did you see how they got tricky in there? So this was really getting at, do you understand what makes a vertical asymptote? And could you apply it? Because I've never done a problem like this before. So it was just going back and thinking to what's the definition of a vertical asymptote? How do we make them? I knew that I need to factor it because vertical asymptotes are made by factoring, right? But I knew that my vertical asymptote couldn't be at sine x. That doesn't make sense, right? We've never written a vertical asymptote as sine x equals something. It's always x equals something.
Well, those two.
Yeah. So it's 3. It's 3. They tricked you. They tricked you.
I thought it was like what you did that one time where you were telling us how to.
And you did that, right? You factored it, right? But you had to keep going.
You get it right because you look right.
All right.
I didn't even factor. I just said in my head. I was like,
Well,
All right. 11.
you said we can't like knock off any easy ones, but I feel like the y equals.
Yeah. I think that was kind of easy.
Well, those were just easy ones.
okay, I'll maybe go to 11.
All right. Let's look at the table. How did you guys do with this one with using the table?
I did it, but it might not be right.
I did it, but it might not be right. All right. So when we evaluate functions that have been composed like this, one function was plugged into another, we have to start with the inside. So the inside says g of x, and what's our direct substitution that we're trying to plug in? 3. So can somebody tell me what g of 3 is?
1.
G of 3 is 1. So what we're actually finding on the top is f of 1. On the bottom, what's the inside? F of 3, right? We're doing direct substitution. F of 3 is 3. So on the bottom, we're finding g of 3. So I already knew g of 3 was 1. What's f of 1? 4. So what's the limit? 4. E. What I'll do, I'll make a video after school finishing these. Okay. All right. So for the next one, this is one where technically we couldn't do direct substitution, right? Because you're not technically allowed to plug infinity in. But we can at least kind of think about this. So I'm going to plug infinity in. If you were doing one of the free response questions, you should never write it like this, okay? Anytime you do a free response question, do not show yourself plugging infinity in because that's not allowed. If we think about how these numbers work, we know that when you plug anything into sine, the answer, the y-coordinate, always bounces back and forth. It oscillates between -1 and +1. So we know that this number up here is somewhere in between -1 and +1. We know that this answer down here is somewhere between -1 and +1. So these ones are not really interesting. The one that is interesting is the e to the infinity. So you have to think, it doesn't really matter if you know what e represents or not. I guess as long as you know that e is not a fraction that's smaller than 1. But e represents 2.7 on your calculator. So any base to an exponent of infinity is going to get very large very fast. So that means that the bottom of this fraction is infinity plus or minus 1. So that's basically infinity, right? Because the infinity absorbs that. And then on the top, we have a very small number. So something between -1 and 1. This is not proper mathematical notation at all. But if we remember what this means, anytime we have a small number and then divided by some number that's super large, that means we basically have 0. So that limit right there is 0. All right. Again, we want our function to be continuous. That means that we shouldn't have to pick up our pencil as we trace it. Here, what we need to make sure is that if we plug -3 into this function, it's going to be the exact same y-coordinate as if we plug in -3, nothing here. We can't plug in -3. But as if we were to plug in -3 to this function. If you look at the problem, you cannot plug in -3 in because that says x squared minus 9, and -3 squared is 9. So you can't actually plug it in the way it looks right now. So that means that I want to take this function right here and I want to simplify it a little bit. So I know that the denominator is x plus 3 and x minus 3. I'm going to assume that one of the factors is going to be x plus 3, and that these factors cancel out, which leaves this one able to plug a negative 3 into it. The reason I'm going to assume that is because it helps me factor this a little bit more easily. So I know that that would have to be 2x to multiply to 2x squared. And then for this to multiply to negative 3, then I know that should be a negative 1. And now I'm just going to FOIL it out to make sure that I did that right. So 2x squared minus x plus 6x, that gives me the 5, minus 3. So that is correct, so that means I can think about this canceling out. Now I can go ahead and actually plug that negative 3 in and see what my y-coordinate would be at that point of this function. So I've got 2 times negative 3 minus 1 divided by negative 3 minus 3. So I've got negative 6 minus 1 is negative 7, minus 6, so that's 7/6. So that means that the y-coordinate up here is 7/6, and as long as this k value is 7/6, then it's kind of like this one has a hole, right? That's a hole, and it's like this point is plugging the hole. So if you were to draw the graph goes like that, it skips it, and then this one comes in and is like, boop, fill it in, so now it's continuous. Now you can trace it without picking up your pencil. So the k value should be 7/6. All right, next page. So this one says, which of the following could be the constants a and b? So here we know that we've got some vertical asymptotes, and I know that those come from factoring the denominator. So I'm going to go ahead and write down, I've got b times x squared minus 3. I want to see where that equals, well, I guess I don't need to set it equal to 0, but actually that could be a way of solving it. Yeah. Anyway, factor in the denominator. Actually, I'm going to do that. I'm going to set it equal to 0. So I'm going to add the 3 over, so that gives me bx squared equals 3. And then I'm going to go ahead and divide by b, and x squared equals 3 over b. And if you look at the picture, you can see that your asymptotes are at +1 and -1. So that means that when we square root this, it has to equal 1. The square root of this fraction has to equal 1. Well, the only thing that equals 1 when you square root it is if you're square rooting 1. So that means that 3 divided by b, it needs to equal 1. And so b must equal 3. So this would be 3x squared minus 3. So that means our b is 3. So that narrows it down a little bit. And then we can just think about, it looks like our a has to be 4 or -4, so we have to think about what happens if we were to plug in a 4 in or plug in a -4. So x squared minus 4 over 3x squared minus 3, x squared plus 4 over 3x squared minus 3. And this kind of comes down to what I was telling you guys, where this stuff is not necessarily in the calculus curriculum. You should have learned about this in pre-calc, but it's kind of shown up again on the AP exam. Is if you look at the last two numbers, if you think about if you plugged in 0 for x and you wanted to know what your y-intercept was, this is how you find the y-intercept. So if I'm using -4, my y-intercept is +4/3. If I'm using +4, my y-intercept is -4/3. So I have to think about which one of those matches my graph, and +4/3 matches my graph. And so that means that -4 is what my a value should have been. So this answer is C. So this question technically could be on a pre-calc final because it fits that material a little bit better than it does calculus, actually. All right, for this one, which of the following statements is true? Remember, if we're thinking about the limit of something, direct substitution is always the way to go. So I'm going to look over here for A and see if this is true or false. I'm just going to do direct substitution. So if I think about log form, this means that 3 to the second power equals 3. And that is not true. 3 to the second power equals 9, so that's false. So it's not A. The limit as x goes to 0 from the right of log base 3 of x does not exist. So I'm going to rewrite this. Log base 3 of 0 to the right, I want to see if it equals something or not. So 3 to some exponent equals 0 from the right side. And there's no exponent that you can use to make that fraction equal, or make 3 equal 0, because 3 to a negative exponent is going to give you a fraction. 3 to 0 gives you 1. 3 to a positive exponent is going to give you a big number. So this is probably the right answer. The only thing that causes me concern is that it didn't just straight up say 0, it said 0 from the right. And 0 from the right, I'm like, oh, are they being technical, where that could just be a super tiny fraction that's close to 0? Because in that case, you really could do that. So I'm going to leave this as like it's possibly the answer, but I want to look at the other ones. Here, we're saying that the limit does not exist as x goes to negative infinity. So here I'm going to say e to the negative infinity. I want to see if that limit exists. And we recall that any time you have a negative exponent, you write that as 1 over e to the infinity. And that limit is 0. That does exist, so this is not the answer. Here we're going to see if direct substitution will work. So cosecant of negative pi halves, we want to see if that equals 1. So I'm picturing on the unit circle, negative pi halves is down here. That's the point 0, negative 1. And cosecant is if, did I do that right? So if I look at this, cosecant of negative pi halves is negative 1. Negative 1 does not equal 1, so that is false. That's a false statement. And then here we want to be able to plug the 1 in, direct substitution. So I've got e to the 1 minus 1 equals 0. E to the 0 does not equal 0, that's false. So that means that our true statement was definitely B. All right, last but not least, we have the free response question. So number 1 asks if f of g of x is continuous at x equals 0, explain why or why not. So remember that continuity includes 3 things. Remember, one of those things is that you have to be able to evaluate the function. So first we want to check to see if we can evaluate it. So f of g of x means that we're going to be doing f of g of 0. So over here, g evaluated at 0 is 1. So that's f of 1. F evaluated at 1 is a y-coordinate of negative 1. So check for the first thing. Yes, we can evaluate it. Second, we want to make sure that the left-hand limit and the right-hand limit agree with each other. So I'm going to say the limit as x approaches 0 from the left side and the limit as x approaches 0 from the right side. So I'm going to write f of g of 0 again. 0 from, I'm going to go ahead and write that I'm doing from the left side. So 0 from the left side is a limit of 1. So that's f of 1. And we know that f of 1 is still negative 1. Zero from the right side, the right side you get 2, so that's f of 2. Over here, if we look, x value of 2, the y-coordinate is negative 1. So here, so that was the first step for continuity, that one works. This is the second step for continuity, the left-hand limit and the right-hand limit do agree with each other. And then the third step for continuity is to say that whatever the limit is, it's the same as what you get when you evaluate it. So step 2 tells us that the limit is negative 1. Step 1 told us that when we evaluate it, we get negative 1. And so step 3 is we're just verifying, yep, whatever you got when you evaluated it is in fact the limit. And so step 3 counts. So explain why or why not. The work that you're showing explains it a little bit. So they give you 2 points for this problem. They say 1 point is for using left and right hand limits, and the other point is for answering yes and explaining yourself. So you could say yes because it satisfies the 3 parts of continuity. All right, part B wants to know if g of f of x is continuous. So again, we're going to use those 3 parts. We're going to do g of f of 0. If you plug 0 into f, you get a y-coordinate of 0. So that's g of 0. and then g of 0 was 1. So that's what we get when we evaluate it. So based on the first part of the definition of continuity, we would say that we're on a good track so far. And then we have to do the left-hand limit and the right-hand limit. So this would be g of f of 0 from the left. So if you look at 0 from the left on this graph, that gives us 0, and g of 0 is 1. If we look at 0 from the right, 0 from the right gives us negative 1. And then if we look over at the g function and see what happens if we were to plug in negative 1, then we get 0. So here we did not pass the second step. The second step was the left-hand limit and the right-hand limit have to agree with each other, and they do not. And so we would say the left-hand limit and right-hand limit don't agree. That's a good reason to say no, it's not continuous. So the 2 points for this problem, one was for using left and right-hand limits, which we did. The second was to answer no and explain yourself. So you could get the points for that. All right, C. What is the limit of f of g of x? Explain your reasoning. As x goes to infinity. So here I wrote that the limit as x goes to infinity of g of x, if you look over at g of x, as the x gets bigger and bigger and bigger, you can see the y-coordinate is getting bigger and bigger and bigger. And so I said that that value was infinity. And so that means that you're taking this and you're kind of like going back and plugging it in for that. So then next we're going to say the limit as x goes to infinity of f of x. And if I look over at f of x, as x goes to infinity, you can see that that's negative 1. So the work that we showed, the value of each limit, that's worth 1 point. And then your answer saying that your conclusion here is that the limit of that composition is negative 1. That's the second point. So 1 point for this work, 1 point for this work. All right. And then part D says we want this piecewise function to have a k value so that the function is continuous. So here is where we just have to think through what makes it continuous when it's a piecewise function. That means we can't have a jump in there. So that means that when you plug 0 into the top function and we plug 0 into the bottom function, you should get the same y-coordinate. Now you do have to be careful here because technically you can't just plug 0 in over here, right? You have to be using the limits because 0 is not defined on this bottom one. It says x is greater than 0. 0 is defined on the top one. So just be careful of that. So here when we look at the points, they said they want you to use a left-hand limit for this one. I don't know if you wouldn't get points if you just plug in 0 because 0 is included here. So I find that kind of interesting that it said you have to use the left-hand limit. So since that's the case, you really should have written it as the limit as x goes to 0 from the left of f of x plus g of x. So f of 0 is 0 and g of 0 is 1, so that equals 1. And then for this one we want to find the limit as x goes to 0 from the right, so that's k plus g of x times f of x. And if you look at the limit as from the right, the limit for g of x is 2 from the right. So it's k plus 2 times, for f of x, if you look at the right side of 0, that's negative 1. So we need, that's k minus 2. So we need these two to equal each other. So these represent the y-coordinates. We need those y-coordinates to equal each other if the function is going to be continuous. So now I'm going to say 1 equals k minus 2. And I can go ahead and add 2 to the other side, and I get k equals 3. So 3 points for that answer, 1 point for the left side, 1 point for this right side, and then 1 point for solving for that k.